Hi everyone. Can you hear me fine in the back? Nice. Thank you. Here's some AWS stickers, and we have some really nice books. So if you ask some great questions, we give out some or all of these books. So this is a very interactive session. So please feel to stop and ask the questions. We are 20 minutes late. We are trying to record this because some students are trickling in. So apologize for the delay. Having said that, I'll get started. I am here. Dr. Bhatnagar, nice to see you. I am Dr. Nistala. I work in the AWS research team. I come from a background in research. Here today, I have some of my esteemed colleagues here, so they will introduce themselves when they get here. And we'll all be in the back, so if you can interact with all of us on any of these topics, if I can't answer something, I'm sure some of these really knowledgeable folks here will be able to. So having said that, a little bit about my background. I just wanted to say that not about filling my resume out, but just wanted to say that I come from a background in research, and I understand some of the use cases and some of the university-specific research settings and subtleties that you have to face while trying to conduct your research, graduate on time, utilize all the campus resources, and at the same time, be successful with research outcomes. So, prior to this, I was leading a team of cancer which is a team of bioinformaticians, I was a lab scientist. So that's kind of similar to a research setting, right? Where you have people working in the wet labs, the really technical savvy, the programmers, the coders. So that's kind of like the background that I come from. So totally understand some of the. All right. So Amazon, we have. It's a big company, right? All the way from Amazon Retail that probably used to buy all this stuff online. To we have Amazon Web Services, which we're representing today. We love science from the company, right? We are obsessed with science, and we do a lot of innovation. We're thinking about how do we enable one-day shipping of all your stuff. So prior to AWS, I did this thing with Amazon Retail for it's just amazing the innovation that we have, not only in our fulfillment centers, but also in the supply chain logistics. Like how do we track an individual ASIN, what we call an Amazon standard identification number or SKU, all the way from where we pick it from the vendors to the delivery at your home, the infrastructure and the logistics behind it. There's a lot of innovation that happens in areas of statistics, in areas of machine learning, everything, right? Then on the Amazon Web Services side, I bet you have followed some of our news around our some of the developments that we have done in quantum engineering. We have a center at Caltech, and you can get access to some of the quantum computers. So that is, there are some scientists that are working on some really innovative things. So just giving you an idea of what the scale of innovation is and what the range of innovation is, right? And then thinking about domains like bioengineering, there's a lot of bioinformaticians, there's a lot of genomicists, there's astrophysicists, anything you can think of, there's innovation happening there, and we love science. You can recognize some of the universities and education enablers here. These folks have kindly agreed to be publicly referenceable. This is just a snapshot of a very small set of customers in the higher education research space. I'm sure you can recognize some of these names. UC San Diego, Stanford. So we are involved in research. Okay, so why are researchers using the cloud? Right? First thing is you would like to have access to analytics. A lot of data, right? Your research is coming from various different fields, from social sciences, from life sciences, from engineering. You need access to analytics, you need access to performing analytics on top of your data. One of the important things is you want to connect your research fast, right? So I have throughout this talk, I put on my lens as a researcher, so that's kind of what I'm trying to map it back to. So faster time to insights, that is a major thing why we do see a lot of researchers using the cloud. Increased collaboration, right? Very often you see funding agencies like NSF requesting that the moonshot initiatives that you're applying for, they're not limited to the one lab, one professor kind of model anymore. These are now very collaborative, coming in from various different centers. The moonshot and the Marshot initiatives, like thinking about life sciences, you have like genomics, proteomics, metabolomics, variables, all coming together to like, to cure cancer, right? Things like that. President Joe Biden, I believe, that the vice president started that moonshot initiative, and now I think it's in two. So things like that, right? We're thinking about how do you collaborate. Collaboration is a major aspect of research. So universities, researchers are increasingly looking to the cloud to enable collaborative research. That's one thing. And then obviously speed of innovation, right? You want to be able to fail fast, right? It's a very iterative process, research. You go do your experiments, you fail, you research, your problems are not working out, your solution does not work where you want to get at. You try to fit it back to a model. So this kind of iterative model, if you don't want to be limited to this set of resources probably that your campus provides, or sometimes you want to scale, right? You want access to that computing. Great if you have a campus center. If not, researchers are increasing the cloud or increasing the speed of innovation. So why AWS, right? I was talking about why AWS. Right? So we have to enable your scaling, whether it is access to your, hey, you know what, I have my small laptop, I want to quickly test something out on a couple of nodes, and then once you have your algorithm figured out, you want to scale it up, you want access to that. It's not thousands of CPUs, right? So unlimited on-demand infrastructure, you can get running like tomorrow or like probably in a couple of hours. If you have an AWS account, you can get started like immediately, right? We have the broadest portfolio of resources. We are talking about data storage, computing, like quantum computing resources, things like that. It is obviously we have a really wide portfolio of resources. That is one thing. I'm calling out like transport technology. So this is something related that I'm getting into. I'm not talking about just like moving data. I'm also talking about moving physical goods. So a lot of research is also looking at that on the supply chain side of things. So all these reasons why people are looking at not only AWS but also Amazon. And then obviously every domain you can think of, now there are innovations that you can artificial intelligence. There are coders who obviously are experts who can start them. Or there are also people like me when I was a researcher. I was definitely not a business coding, right? I wanted that plug and play capability. I have all this kind of data, and I wanted access to the scientists for that. My application that could pass through my data to doing that feature recognition. Or one of that plug and play resources. There's a lot of researchers that want applications on top of their science. They're not in the business of coding. They're not in the business of developing machines. So that's also one strong reason why we increasingly see researchers. So simplifying workflows. So what that means is better return on your investment. You work very hard for your research dollars. You go through multiple iterations of submitting a grant even before you submit it. Once you submit it, you get feedback from the program manager, from the program officer at NSF. You have to make changes, and finally you may or you might not get your research dollars. Right. So how decreasing that process, the time process, you have a better return on investment and faster time to insights. We discussed that. So in the next couple of slides, I'll quickly go through some conversations and trends that I'm seeing. Giving us opportunity to work with universities. So here are some insights that I see across the board. The existing low-cost solutions, and for example, your Google Drive, right? A lot of you, and I used to do that when I was research data on your Google Drive. Very soon, you'll hit those limits. And then from what we understand, some vendors are actually changing their pricing model. So what you're used to, your no-cost storage, your storage resources are not going to pay forever. There is a change in pricing happening. So suddenly your university or your research IT is looking for, okay, now this is not free anymore, and there's some researchers who are looking for where can I put all this data down, right? And on the flip side of it, sensors are getting cheaper. So every researcher, whatever field they're in, is generating more and more and more data. So data storage, way to do it, how to securely do it, is going to be a very important consideration. We see increasing instances of ransomware, research espionage, right? There are many cases of that. So gone are those days where it's okay to just put the data to have and carry pocket. You should be thinking about securing your data. And increasingly, you see that your funding agencies are mandating that. They are not okay with you storing all this really sensitive data. Expensive because you're spending a lot of research reagents, time in getting this data, right? So this is very expensive data that the funding agency is paying for, your school is paying for. You don't want to throw that away or use it. So think about how to secure your data. As I said, increasingly FDA, sorry, not FDA, mandating that your research data is shared. You cannot just put it in a silo in your computer. Once you generate something, you'll be able to share it. So that means that is a trend that we see across the board. And then innovation, right? Gone are the days when you generate all this data, you run out of room on your hard drive. Oh, this is 5-year-old data, let's get rid of it. No. You want to train your machine learning algorithm, suddenly you need like this petabytes of data. Where do you get that? Because if you throw away all your research data, your old starting data, you don't want to hang on to your research data. So these are some things that are the decisions that you have to think about while by the way, quick show of hands. Are there any research enablers here, or mostly you're all like students and performing research directly? Of course, I think professors too. So mostly students. Okay, cool. One other trend is, so there was from when I was in research years ago, we had a local desktop, we had a local, right, or a little bit of a local area network research where we do a foundation, it stays there. But the model has changed since then. Not accessing your local Active Directory base or your local land research anymore. Now more and more researchers are getting into research of notebooks, whether it is RStudio, Python, or even like MATLAB. They are coming into this model of like sharing like notebook-based research. So going from local lands to notebook-based research that are shareable, that are accessible by remote users, right? And then containerized approaches. You want to share your common compute pipelines. You create a pipeline, you want to be able to share it with your collaborators globally or across. So that's a change in the research models that we're looking at. And very often we see researchers doing that on their own scale out training jobs, right? You test it on a data set, but then you want to talk on larger data sets that are probably not local. Right? And we see this across the board, like all the domains. It's not specific to one domain. We see these trends across the board. So going back to data, quick comment. So what do researchers want out of their data? Data is growing exponentially, right? What are the factors for that? Inexpensive sensors, more of these big moonshot initiatives, cost of computing or cost of like research hardware is decreasing. There are more and more initiatives, like for example, Howard Hughes Medical Institute, right? It actually gives you access to these really expensive hardware. So you don't have to spend all your money. So when you can get your research data, you don't have to buy that expensive electron microscope because it's probably on loan from HHMI. So that means you have more money to spend. So you are generating all more data. Your data sets are becoming better and better, high resolution images, right? You get gigabytes and gigabytes of images. One light sheet experiment, you're probably generating like and that's probably looking at a small piece of it. So whatever research area you're looking at, data is growing exponentially. It's coming in from various news sources. Innovations happening. And used by many people across the board. So and what do you want to do with it? You want to put in like various layers of analysis on top of it, right? I gave you that example of genomics, proteomics, variables, and they're all looking like probably the same set of applicated data, right? Being used by many different applications. So researchers want more value out of their data. is one broad. Also think about how would you enable that. And so traditional storage do not meet all these things. Right? You have this huge administrative admins to help you save it, to keep the integrity of your data so that to repeat your experiment your data set should be managed. It's not scalable if you keep it locally, obviously it's not, and it's not a job. Right? It took us like 20 minutes to actually get on it. So this is just a quick. So why I'm saying all this is because I think cloud has an elegant way of doing all cloud has a solving all these problems. And that is, like your data is residing in silos. And I have this example here where in your data silo 2, you're aggregating all this data, you're keeping it local to one research group, but research group 2 is not one, which is probably, right? So the modern way of thinking about it is, you want to be able to aggregate all this data. It should not be limited to one particular set of data. It should be multimodal data. You should be able to put it all in one repository. You should be able to access for all your analytics and right. That those analytics should not limit your ability to get the output that you're looking for. And you should be able to move data from one user, from one analytics store to a different kind of analytics mode. So all these, we have a term for call it the modern data architecture. And this unstructured data repository where you throw in multimodal data, we call it a data lake. So that is how we are configuring or we are to get to that stage where moving data, sharing data, doing various multimodal analysis on your multimodal data is not a problem. We have a way of doing that, and that's what we see. We are helping a lot of researchers. I'm not going to go into details of how we're doing that. That's not the but if that is something you are thinking about, or if research looking at something like that, how do you get all this microscopy data, wearable data, or some genomics data? I'm just giving life science examples. But if that's what you're looking for, talk to us, and we would like to work with you on the details and see if we can collaborate. I'll just last point about data, right? We're talking about all this data. Very often researchers ask me, I hear that cloud storage is expensive. I would caveat that. We have like I believe 7 or 8 different storage tiers. We have the hot storage tier that we call the S3 standard frequent tier on one end, where you get access to it immediately. The latency is like super low. And all the way down, we have a glacier deep archive where the latency is like a few hours, but that is the most inexpensive form of storage. And we have all the flavors in between. Or, for example, I was talking about the use case where for example, your microscopy data you generated some data a long time ago, you want to hang on to it, but you're still not sure if you're going to get that one source of funding, then you might need it right away. If you're not sure of which storage tier you want to put your data at, we have something called the intelligent tiering, which automatically looks at your data access patterns and then automatically moves your data to the right storage. We also have a new tier that we announced recently called the instant access instant access tier, where it is still in the archive tier, but then you get access to it right away. That is something I've been talking to a lot of. So it's inexpensive, but still your latency is pretty low. So that's a good way of stretching your research dollars. I spoke about data lakes, so that is those researchers that need to all these multimodal data together. Think about data lakes and how they can help you out, and we'll be glad to talk to you about that. While I'm doing that, this is an important consideration. We have an expert here, Scott Friedman, on security of data as well, so very often, like for example, DoD is mandating that if they are going to fund you, then you have to have a compliancy to be able to do that DoD research. We are also coming across use cases like SIPs, which are secure, compartmentalized information facilities, like super secure, super secret research. That's kind of what you're doing funding. We can help you do those skills or get your certification so you can perform your highly secure research. About 117, or this is a little older information, but probably more than that. Most of our AWS services that are compliance eligible. And if you're working on, let's say, PHI, patient health, any data that has like your personal information, then you are probably looking at your compliance. And whatever your compliance needs are, most of the AWS services are able to do that to meet your needs and any of the certifications across the globe. So talk to us about your security requirements and compliance requirements, and we'll be glad to discuss. Yeah, so this is my favorite part. Last year, I believe, David, you did a hackathon here, right? Great. So this is a use case that came out of the hackathon, and one of my favorites. So at UBC, right, COVID was just at the beginning stages, and not many researchers knew about what is the structure of your COVID variants, and then the variants are changing by the day. So this researcher, Adam Baban at UBC, he decided there's a lot of readily available sequencing data out there, right, publicly accessible. What if I use this data, mine this data for their RNA sequence, and then use it for prediction of structure or prediction of the presence of a virus within this publicly available data? So that would actually help us figure out what are all these new variants that are coming, right? So he decided to use publicly available data and was able to analyze over 1 million libraries of NGS data that was available in a day for a cost of less than half a cent per library. And they were able to find 1,000 new viruses that they were able to predict within publicly available data. Just no one was doing that. Just because COVID happened, someone thought about it in a very different way. And that idea actually came out of a hackathon on campus at UBC. And that hackathon, his proposal was the Ceratus project. And the Ceratus project is now a public repository of COVID-like variants from publicly available data. So that's a great use case of how researchers were able to use publicly available data, do analysis, and respond quickly to understand and RNA variants or RNA structures for COVID-like viruses. That's a great example, right? So just think outside the box. It's not always that you have to wait for someone to come up with the next grand idea, right? And do take advantage of all these hackathon kind of events that are happening on campus, and then ideas, go network, go talk to the researchers, like, hey, what's available out there? What can we do? Or if you have any idea and you're looking for, oh wait, I don't have computation for that, I don't have data for that. Email us, and if we have any ideas, we'll definitely talk to you. We have something called the Registry of Open Data, which has like 400 plus high-value, publicly available free data sets. And it's like not many researchers know of that, and not many researchers use that. But you should be doing that. The kind of data is not exclusive to life sciences. We have image data, we have microscopy data, we have genomics data, we have astronomy data, all kinds of data. We have multiple compute options. I'm not a technical expert, but I'll briefly describe what we have. If you're looking for, this kind of just like simple compute, okay, I have outgrown my laptop. Our equivalent service is called Elastic Cloud Compute, EC2, which provides you access to different kinds of instances. We have containerized services for your Kubernetes as well as Docker's kind of services for ECS, Fargate, and EKS. And quite often we are running into these use cases where researchers don't want to continue to power on an instance that they're not using. Instead, they want trigger-driven events, like, okay, here's a data streaming from a sensor. I want to quickly analyze that only when the data is being streamed. I don't want to keep the computer on all the time. We have our serverless services like AWS Lambda, right? So if you're interested in to an expert. David is just an expert and he's an expert in that. Feel free to reach out to him. We in our EC2 we have like so many different flavors. We have high memory optimized, we have high networking optimized, we have GPUs, we have bare metal instances. So if you combine all these different options, it's probably 300, 400 plus kinds of instances, and we are innovating all the time. So every reinvent, we are probably like announcing 2, 3 new kinds of instance families. So this is only going to continue to increase. And for your specific CRD workloads, or for your imaging workloads, or for your high processing workloads, there is probably already an instance type that has been optimized for that one specific research workflow. So do talk to us about how this unique use case, but I'm not sure, I don't know which particular instance you use. We can help you with that. We have different pricing models as well. On demand one, where you have your computation right away. And on the lowest tier, we have spot instance, where all the unused capacity is provided at a discount to you. But the caveat is that once there is demand for that, it's probably taken away. But you can do like some really creative ways with your architecture that your research is not lost when the instance is taken away, but still you can avail that 90%, up to 90% of discount on accessing compute. So think about how you can stretch your research dollars by utilizing spot instances. Here's an example. So going back to the EC2 instance types and how we probably have like a different instance type for a different workload, research workload. This is a blog that just came out like 2 days ago that I was a part of. This is a study from Stanford University, where they have come to us and said, hey, you know what, you have all these different instance types, and researchers really are not sure which one to use for which workload. So we're like, that's a great problem. We're aware of that. Let's work on that. We have a solution. They said, yes, we actually worked on a solution for Hummingbird, where you can take different genomics pipelines, sample your data set, where your data set at 0.1%, 1%, 10%, 100% data set, and you can run the small test workloads on different flavors of instances and figure out what is the best instance that will give you the best bang for your buck, what is the instance type that will be the fastest for your workload, and what is the instance type that is a balance of, or no, that is the cheapest. These are the 3 different variables, and this research tool that we built, Hummingbird, will help other researchers figure out the best instance type. And we're like, you know what, that's great, that's a value add that you're giving to us. So let's work with you on that and we publish this blog. So there are tools like that out there that will help you find the right instance type for your right workload. If you think of any of such use cases where you believe there's a gap in an existing service and you think you can add to that, do talk to us and we would love to collaborate with you. So I just want to call out that Hummingbird came out of Dr. Mike Snyder's lab at Stanford Health University. This is a great example, Children's Hospital of Philadelphia. Anyone in the life sciences area here in this group? Mostly EEE, okay, or computer science. Anyone on bioinformatics side? Anyone does? Okay, so okay, let me caveat by saying that DNA sequencing is a large workload. It takes a long time upstream to create your libraries, the actual wet lab part of it. And then once you have the libraries done, once you put DNA sequencing, it takes a really long time to get your raw sequencing out. And then there's the analysis part of it, where you have to parse this data to look at these things that give you like the genome. So I said all that saying that each run, Children's Hospital of Philadelphia, they have sequenced 1,000 pediatric genomes. And when I say genome, it's a whole genome sequencing. It typically takes like the workload, sequencing takes 12 hours, upstream takes like 10 hours. So we're talking about 24-hour workloads. They've done 1,000 of those in 2 hours and 25 minutes, only on sequencing side, experimental side. But that kind of like tells you the power of utilizing cloud computing, like scale-out computing, on-demand computing, for getting your output fast, right? So if you're in a time crunch and you want on-demand access to your computation, look at the options in the cloud. This is enabled through our partner, Edico Genomics, using the Dragon is now owned by Humana, but this is done using one more example where UC Santa Cruz, they were looking at variant different sequencing data for those clinical outcomes, right? So if anyone knows a little bit about diagnostics, there are two kinds. There are diagnostics where the doctors or clinicians have already developed a test to look at a very small portion of the genome for that one specific variant and the output of such a test. For official diagnostic, quote unquote diagnostic, gives you an output of yes or no kind of an answer or presence of a variant or not, right? So there are a lot of use cases where people come up with ailments, diseases, or disorders that do not have diagnosis, where doctors, clinicians are like, I have no clue what's going on. And you have to look through the whole haystack to figure out what exactly. So typically, researchers, what they do is they match the newly sequenced data of their patient against existing data sets to get to those observations, to get to those outcomes. So there is no ready-made answer for such use. So in this use case, UC Santa Cruz has actually used AWS for these what we call these orphan cases, right? To match all this data against existing data sets to get at those outcomes. And they were able to do that in a very rapid time frame. It's one of those cases where research is actually changing outcomes of people's lives. And some of these use cases are being done on the cloud. So I wanted to, like get you excited about what's possible on AWS and what's possible on the cloud. One more example. So as you can see, a theme of my talk, I'm not trying to, sell you specific services, but I'm trying to understand or trying to showcase use cases where it could probably like set off an idea in your brain, like, oh yeah, maybe this relates to something you're doing, and let me talk to these guys or something. In this use case, again, like talking about scaling out, Benson was able to do these top-fill modeling experiments, which typically are very computer intensive and take a long time. Clemson University was able to utilize 1.1 million vCPUs and was able to process all this and do this top-fill modeling experiments in like a really short time, like 2 hours or so, with an average cost of let me see, the 1.72 cents per core hour, which is just like incredible. And they were able to get that scale and that level of value for the research dollars using on spot instances. This is one more use case for like geospatial studies. So geospatial data sets, they have like this huge data sets from satellite imagery, comes with a lot of storage requirements, and you have to have institutional commitment to geospatial data for enabling geospatial research. So this is a very unique take on that. This is an NSF Big Data funded research. There was an incident in Nepal, like I think it was an earthquake, and this research actually used data from social media to analyze social media images and come up with some kind of a new metric called the damage assessment value as an indicator of how extensive is it. So through this approach, they were able to use machine learning from social media images that didn't have to be stored locally, and they were able to utilize the cloud to analyze such outcomes. So they're pretty much like disrupted. If you ask me, right, that's such a disruptive thought experiment. Let's not store data locally. There's all this data already being generated on social media. Can we use that to come up with outcomes that are useful for research? So really cool use case. We have a large community of customers and partners. We have, if you look at our AWS market, we have more than 2 million subscriptions. We have 1,000 plus products across 65 different categories and domains. We have 2,000 plus ISVs, independent software vendors. So if you think that, oh, there is this really cool software by this company that knows about, but that is great for my particular experiment. So now how do I match this software that is probably operating in a silo to this computation need that I have, but probably I can get these two parties to talk to each other. Probably you have the solution at this ISV on our marketplace, and we have what we call the quick, what's the word I'm looking for? Quick reference architecture or quick start, yeah. So we have like these quick starts where we have some of our solution architects have already brought these softwares to start running on the cloud at the click of a button, and we have a lot of those quick starts.
A lot of software on the marketplace.
Oh yeah, totally. So how are we doing on time, Dave? 7 minutes. How about I kind of like finish my comment? Is that good? So we have so going back to this whole thing, collaborative research, where we understand that you would like to collaborate with your colleagues like across campuses, across universities, probably even globally. And how would you move your data, right? How would you provide access to your complete pipeline, your very unique data set to your researcher out there, and how are you thinking about all this process? We have options for you. We have native options that are built on AWS, and we also have options that are provided to our extensive partner network. I throw out a few names, they probably don't mean anything to you, but talk to us about collaborative research and how we can help you with that. So we have Service Workbench on AWS, we have Rescale on partners, and so we have all these click button research options for you if you're looking at collaborative research options, research gateways. Okay, so Steve, I believe, is also talking about AI/ML. So in the interest of time, I will skip the AI/ML piece of it, except saying that there's a lot happening on the innovation kind of thing on the cloud. There is also a future talk on that, so we'll get to that then. And finally, most important, resources to use. So if you go to this page, this on science page here, if you are looking at, okay, we are going to go apply for this funding, right? We saw that many times if you include some data set within your proposal, call for proposal, and you're applying to that. Hey, we already thought about this experiment. We've conducted this experiment. Here's the data looking like. Now we actually want to go do that. So that bridging between your application for funding when you get the result versus now, that could be a space where we could help you. You could probably build that architecture for you in the cloud, and then you can do that proof of concept study. So think about that space where you're applying to funding and you need computation. We can help you there. We can provide you a letter of support. And we work with NIH, NSF, NASA, and a lot of these government funding agencies on programmatic approaches to enable you. Right? We have like tutorials, we have like videos, and we have a lot of resources. And I'll skip the data ingress waiver, but the point is that downloading data from the cloud doesn't have to be expensive, and particularly in the research setting, it is probably free. How we get to that, it's a programmatic approach, but I can talk to you in detail outside the talk. But my take-home point is downloading data from the cloud is not expensive. Finally, yeah, so this is an example. This is again like one more blog ago. NSF is not, it's listening to researchers. It's not the traditional model where you think that your research output is a publication, right? So you get funding from NSF. It doesn't have to be a paper that you publish. Your output could be, here's a startup, right? You know about the SBIR grants, right? You're spinning out a company. Or you're creating a product that could have an impact, downstream impact. It doesn't have to be a paper. NSF knows that. It's listening to us, right? Researchers. So it came up with this convergence accelerator proposal, call for proposal, right? And here's a use case where we help UC researchers get their funding for the NSF convergence accelerator, and they were looking at monitoring and tracking like animal disease and animal health. And please, when you get a chance to get that blog that we published, it has details of how we help UC Davis get that NSF convergence accelerator fund. All right, so what's next? Check out this page and talk to us about anything I'll be here the whole day. We have so many of us here. So, if question is, please do talk to us. And I believe I'll stop here, but you have, I don't know, 2 minutes for questions. Yes, please. Oh, yeah, it's called our open data program. It's called Registry of Open Data, or RODA.AWS, or what I can send that link. Or just Google for Registry of Open Data. Yeah. Sure. Audio data set, yeah, actually, I was looking at some use case 2 days ago. We have 2 data sets for audio. Looks like you did a really good job, no questions. Go ahead. Mhm. Great question. I'll probably leave it to depends on the data set. Some data sets are provided on the data set, but you're now in campus, internet, here sort of work that you're doing, based calculated on the total amount of based on all the compute and the percentage of the egress charge. So, in all my years of doing this, I have a lot of people usually big part arrangements
The key thing there is make sure you request your AWS ID for your university. That's right.
Yeah. Any last questions? Dr. Bhattacharya, how about you? Sounds good. I hope this is useful. I hope I got your yes, but thanks a lot. This is a great opportunity being here. And before I go, I just want to say that I got some here on campus and this is great. So, go, go back. Yeah, go back.